Okay, previously we had covered how we're going to map our but I don't know, I cannot auto accept. I need to open, then it's auto. See, last time it's okay for the auto admissions, but now I need to open the Google Meet, then it can accept. If not, it's just hanging there. Okay, so last time we did learn on our CAMAP. As I already mentioned, what is the purpose of CAMAP? CAMAP is for you to help you to get the simplified versions of your Boolean expression. So that is why CAMAP is important. Although you can have basically your true table, but the difference between true table and CAMAP is CAMAP you have the sequence of like 00011110. So you can see normally for your two table, you're going to write 00011011 and following the sequence of 1 until whatever. Let's say you have this part is 2 input, 1 you're going to have 0 until 3. Yes. So for CAMAP, you need to follow the rules under CAMAP, which is you have 0001 and then 11. What is the purpose you draw like that? It is because for you to do a grouping later on. If you didn't do that thing, which is you didn't follow the CAMAP rule, you do 0001 1011 and you mapping your whatever value for the output. Then let's say you group like this and then you have this part. So your output for your Boolean expression will be wrong. So please make sure you map it correctly. Then you will get the simplified versions of your Boolean expression correctly. So you did learn last time in each cell for this cell, it has its own Boolean expression. How you going to see your Boolean expression? It is not the Boolean, it is the product term for your SOP and sum of product for your POS. And all together, when you combine, you get your Boolean expression. So each of these cell, it has its own product term or sum of product. So let's say for this cell, the red color cell, how you're going to determine your SOP value, because this is the output of 1. You need to still remember back for SOP, A equal to 1, A bar equal to 0, and your output will be 1. So when you see all of this is referring to your output, when you see that the output is 1, it's totally under SOP. So for this part, how you're going to determine the product term, because under SOP it's going to have product term. So you need to see the input. Where is the input? The input is at this side. So how are you going to see the value of each input? So you look up, you look your left side. This is all the input value. So now you can see C equal to 0, A equal to 0, B equal to 0, C also equal to 0. And under SOP, 0 will be bar. So your product term here will be A bar, B bar, C bar. So let's say you have at this side. How are you going to determine your product term here? So your product term here, you're going to refer to the upper side of the cell and the left side of the cell. C is equal to 0, only A is 1, B is 1, and you refer all of these to your SOP because the output is 1. So it's going to be A, B, C bar. Okay, that is on very easy because if you have this circle, so you can get this as your product term. If you have this circle, you're going to have this product term. So how if let's say you are grouping it like this? Last time we already learned how we're going to get the product term of this group. So we're going to do similar thing. We look one by one. Okay, if we group like this, what cell we cover? So we cover this part because we group these two, right? So the cell we cover is the cell, the red color. So you need to refer upper and the left. You check for the upper side first. Our C is equal to 0. And this upper cell, our C is 1. As I mentioned, if you have changing value for the cell that you cover, you will ignore this input. So you look at your left side. For this cell, it is A is 0, B is 0. For this cell, or second cell here, you're going to have A is 0, B is 0. So you can see there is no changing at the value. So you're going to pick A and B as the product term. But you see the value also. Because this is SOP, A and B is 0, that's why you will get A bar, B bar for this group if you circle these two. Where I need to accept. Okay. Where is my phone? Jadi ko mama. Sekejap depan kereta. Okay, continue. Just now we learned the Boolean expression for this group. Now we're going to look into this part. Why this? Because there will be no possibility to have 4. So we go for 2. Now for this part, what we'll cover? We're going to cover these cells and these cells together because we already grouped it together. So first cell, for this cell, we're going to look up. Our C is 0. Second cell, we look up. Our C is 0. So we're going to take this and see the possibilities. Oh, I think I left my phone at my house. I remember now. Okay. Then for this left and this part, first cell here at the left, our A is 1. Our B is 1. And the second cell, our A is 1 and our B is 0. So I can see this is fixed. I'm going to refer to my A for my product term later. But my B is changing, so I will ignore my B. Looking into C and A, our C is equal to 0. It's going to be C bar. Our A is 1, so it's going to be A. So this circle, if you have this circle, you're going to have A, C bar. And just now, for this part, you have A bar, B bar. So your final simplification version for your Boolean expression is going to be A bar, B bar plus A, C bar. I hope that you know how to group. Okay, last time, if you were given with non-standard, what you're going to do, you can have the possibilities for you to do standardization. But instead of doing the standardization for only missing one variable is okay, because you only have one step like that. So didn't require you long step and taking too many time for you to spend to do from non-standard to standard. But if let's say you are missing 2 variables, 3 variables, and etc., so it's better for you to do the logic thing, which is you fix the value that available here, which is the value is 0 because it is A bar. So now you're going to have possibilities for missing part is B and C. What is possibilities for B and C? It's going to be 0, 0, 0, 1, 1, 0, 1, 1. And you combine the fixed with the possibilities missing variables. This one is A bar, this will be B and C, which is you don't know whether it is B bar or C bar. This is the things that are missing. B and C, whether it is B or it is B bar, whether it is C or C bar. So this is the combination. So you combine it together, you're going to have 0, 0, 0, 0, 0, 1, 0, 1, 0, and 0, 1, 1. And all these possibilities, you're going to have 1 for the output because this is SOP. So just recap what you have learned also. This one is how you're going to group. So after you have group, let's say for this side, you're going to come out with your Boolean expression. So like this, for this group, you can see here, as I mentioned, you need to look into the cover part there. For this side cell, you're going to see C equal to 0, D equal to 0. For this cell up here, C equal to 0, D equal to 1. So you're going to ignore this because it's changed the value. Now you're going to refer to C later on. So for C here is having equal to 0, it's going to be C bar. Next, you look at this side, left and left part here. First here, A equal to 0, B equal to 0. At the bottom part here, it have A equal to 0, B equal to 1. Because it is changing in the value, going to pick the A here, A equal to A bar. So you combine it together, you're going to have A bar, C bar for this square group here. So this is how you're going to come out with the Boolean expression, etc. You're going to look over here also. This side I already also explained in the video. Wait. Mama tinggal kat rumah handphone. Okay. Then you can see here, if let's say you have 3 variables and you have 4 variables, it's going to be different in terms of product term. If you group it one cell, you're going to have 3 variables for 3 variable maps. What is 3 variable map? You have 3 inputs. And if you have a 2 groups, you can see you have 2 cells group. You're going to have 2 variables. So you can see there. And this is the different. If you have 4, you can see at this side. If you have 4, you're going to have 1 variables. And let's say if you have, okay, all together you group like this, 1, if okay, if you have all 1 over here, your output will be 1. Then your F will be 1. Why is 1? Whatever input you're going to have 1. Whatever input you're going to have 1. You can see here. So that's why your F will be 1 for grouping it if you have 3 variables. Okay, now like if you have 4 variables of maps like these, K-maps, you're going to have 1 cell. If let's say you are grouped like this, you're going to have 4 variables. Let's say over here, you're going to have a CD, A bar B. Sorry, salah. A is 1. A, B bar, C, D. This is the SOP value product term there. You can see you have 4 variables. If you have 2 cell group, you're going to have 3. If you have 4 cell groups, you're going to have 2. If you have 8, that is 8 over there, you're going to have 1 variables only. And lastly, if you have all 1, 1, 1, 1, 1, or maybe X, 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 you can also having a possibilities to group like this, which is 16 cell, F equal to 1. Because what? Because all the possibilities going to have output of 1. Okay, that is what you cover last time. And in the video, I already show you how you can convert from your truth table to your K-map. And from your K-map, you can also come up with your truth table. It's basically similar. Vice versa, it's not too hard because it is similar things. Only the difference, as I mentioned, the flow. Normally, you're going to do from like 0 until 7 here. And for this side, you follow the sequence of 0, 1, and then 1, 1. That is the only difference from your truth table and your K-map. You can have this type of K-map. You can also have this type of K-map, A, B, C. As long as the following sequence is 0, 0, 0, 1, 1, 1, 1, 0, you're going to have the similar answer. Next, you can see you can also have the don't care. What is the don't care? Don't care, you're going to put at the input of invalid BCD. So what is the invalid BCD? That's why I mentioned to all of you, you're not going to cover your module 2 in your final exam. In your task 2, you're not going to cover module 2, but the knowledge they still will be bring to your task 2 final exam, which is if you don't remember what is invalid combination for BCD. So you like hanging, what is this? I don't understand. So if you still remember, it's good, then you know, okay, this is invalid combination for BCD. So all the invalid input here, your output will be don't care. And what is the don't care output? It's going to be X. Normally, your output, you're going to have either 0 or 1 for your digital, right? Because you're going to have 0 and 1 only. But for the input and the BCD invalid, you're going to have don't care, which is X. What is don't care mean? It is have the possibility whether it is 0 or it is a 1. Sometimes you can assume it as a 0, sometimes you can assume it as a 1, depending on the scenario. You can see if, let's say, you have, okay, this is the things, you can see, you map it to be X, 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 X for the input of invalid BCD code. And this is how you map from your two table to your CAM map. And you can see here, you are mapping, grouping it like this because you assume X here to be 1. You're going to go for, as I mentioned last time, you're going to go for the maximum. If you can go for 16, go for 16 grouping. If you don't have 16, you go for 8. If you have possibilities of 8, although it is X's, you need to group it to be at also. Then after that, you're going to have 4, 2, and lastly, if you don't have all of this, you go for grouping 1 only. You can see here, there is a orange color. If you didn't assume X to be 1, you will group like this also, only 2 cells if you didn't assume X to be 1. So your output will be A, B, C plus A, B, C, D. Instead, for you to have the simplifications, when you assume X to be 1 here, and then you group to the maximum, you're going to have F equal to A plus B, C, D. So try to look into it, and you're going to see that, oh, okay, now that is the difference. So there is the output for with don't care and without don't care. Please go through the video I provided in the e-learning. So at this side, alamak, kenapa dia? Okay, there is several exercise. I already also explained in the video I uploaded in the e-learning. You can see you were given with the question, use CAMAP to minimize the standard of SOP expression. So you are lucky at this question. It is a standard SOP already. No need for you to do standardization. But you are given the things which is use don't care term for D67 CAMAPs to produce better result. So if you have this kind of question, don't panic. Basically, this is your don't care. So where don't care will be applied into your CAMAP, it is at the 6 value input and 7. This decimal you're going to convert to binary, you will get 1, 1, 0, and this side will be 1, 1, 1. So at the input of this, you're going to have X, which is don't care. which is referred to D here. So this is the 1, 1, 0 and 1, 1, 1. So you put X's here. So because of this X, you can see you're going to group 1 here to 1 here, you get 4. I know that sometimes you can see, Doctor, I can group like this also, right? But if you have like this, you can group another 4 here, so you can ignore the X here because it is not helping your 1, because your 1 here is already having their groups. No need for you to group the X anymore. The X is only for you to help in terms of if it is not enough to be 6 to be X. So X's is good for you to be combined. But if let's say it didn't help anything, so no need for you to care. So here you can see you need to assume it to be 1 because it's going to help these 3 1 over here to be 4 cells groups. So that's why you will assume it to be 1. Okay, I continue. Okay, now there is a second example. You can see now you were given the different this, or you already learned this is your sigma, right? Sigma, you know it is a SOP. No need for you to been given the hint that it is SOP, or no need for you to be given with the standard or non-standard, because it's directly give you the value of the input. So you what are you going to do? You're going to convert all the value of decimal here to be binary. You will get 0, 0, 0, 1, 0, 1. Okay, this is will be 4 input. 0, 0, 0, 0, 0, 1, 0, 1. Why I said it's going to be 4 input? Because if 3 input, the maximum value for decimal, you're going to have 7. If 4 input, the maximum you're going to have 16. 16 in digit, the maximum will be 15. So here you have until 11. For 8, 0, 1, 0, 0, 0. 9 will be 0, 5, 8, 9 will be 1, 0, 0, 1. 11 will be 1, 0, 1, 1. Okay, so for this input part, your output will be 1. And you have the don't care at 1, 2, and 10. So you will have 0, 0, 0, 1, 0, 0, 1, 0, and another one is 1, 0, 0, 1. So your output will be X. So let's try to draw our chem map. A, B, C, D, 0, 0, 0, 1, 1, 1. 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So the value of 0, 0, 0, 0, 0, it will be 1. 0, 1, 0, 1 will be 1. 1, 0, 0, 0 will be 1. 1, 0, 0, 1 will be 1. And lastly, 1, 0, 1, 1 will be 1. So finish at this side. Now I look into my D, which is don't K, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0. Hey, I think this one is salah. 10 will be 1, 0. This one is 1, 0, okay? 8 plus 2, this 10. So it will be 1, 0, 1, 0 at this side. So this is my true table. So okay lah, I put 0, 0, 0 just to complete my true table. Now I'm going to do grouping. For grouping, I can see this is my 1 here. Is there any possibility to have 8? No, because here is 0. I can have the possibilities to have like this. So this will be my first group. And then let me see another one here at this side. I cannot have 4. So might be I can only have like this. And there is another one here missing grouping. So I can group it to be 4. So for this side, I will get A, B bar. For the purple color here, I will get C bar, D, and A bar. And another one, square there. The orange color, I'm going to get C bar, and this one is, sorry, my A is changing, my B is remain, so I'm going to have B bar. So my final will have, the simplification will be A, C, D plus B bar, C bar plus A, B. So this is how you're going to get your simplification version for your Boolean expression using your care map. So please try to do all the exercise. And after that, you have POS, which is totally similar. What is the difference? The difference only in the expression, which is you're going to have sum of product, which is F equal to like A plus B, and then you're going to multiply B plus A bar. So this is example. So this is the expression that you need to remember under your POS. And the things that you need to refer, which is at the zero output. That is the only difference. If you have like this table, you will have 1, 1, 1, 1, 1 if you map it like this. And the one that you need is POS. You're going to refer at 0, 0 here, and this. So from this, the similar things, you're going to refer to your up, you're going to refer to your left. Look at the input that did not change in the value. So at this side, the value is C equal to 1. The D is changing. So going to look into C is 1. And at this side, A is 0, B is 0. So remember back, POS, A equal to 0, A bar equal to 1, B equal to 0, B bar equal to 1, C equal to 0, C bar equal to 1. And your output will be 0 because you already grouped the 0. Now you can see 1 for C. So it will be C bar. A is 0, so it will be A. B is 0, it will be B. Going to have like this. Why you have this plus plus? Because this is the POS representation. Okay. So you can see here at this certain cell is already also having the value. You can see if you combine this together, when you group like this, when you combine, you're going to have this plus this, while you're going to have the similar things. But when you have A bar plus D bar plus D, you're going to have 0. I think so. So please check. That's why you're going to ignore the D side because it's changed here. That is on the simplification. But instead, you're going to look like this. You're going to name all the cell. Why don't you directly group and look at the different or the same value? Someone want to join? Saya lupa nak pergi rumah cikgu. Balik sini. Hari tu saya cakap dekat cikgu saya nak balik, nak pergi jumpa dia. Aduh, lupa lah. Cikgu sekolah dulu ya. I still contact my cikgu. I think you baru habis belajar. Baru habis sekolah kan. I think you also need to be close with your like cikgu, teacher. Dah berpuluh tahun still contact also. Okay, now KMAP. KMAP simplification of POS expression. Sama, it's similar, which is the different only at the POS. It is totally same with your SOP. The difference is between the value. If you were given this POS, A will be 0, B will be 0, C will be 0. So at this input, your output will be 0. And etc. That's why you will get like this. Then you're going to do the grouping things. Similar, you will get. So all of this I already shows you in the video also, but I just speed up because it is basically similar. And the thing is, you were given several example. You can try. Before this, you were given standard versions of POS and SOP, which is very easy. But when you didn't have the standard version, you need to do apply the rules, the law, and also your theorem to get the simplification version. So if you have like this, you don't know whether this is the simplification versions or not, right? But after that, how you're going to show it in terms of KMAP, then you go for, you can see, it's go for standardization. You can do the standardization like this, but you can also like having 0 and then the possibilities of B and C missing there. So you can also do the mapping like this. And I think only that for your module for B. After this, you're going to see on the logic circuit for your module 5. But before you go to module 5, you will see that you have the simplification version if you use your KMAP later on. So you were given with this circuit. You don't know whether it is the minified versions or not. Of course, it is not. Sometimes it is directly give you very complicated circuit. So what you need to do, you need to come out the expression, the Boolean expression first, and from here you map to your K-map, and then you will get your simplification using the K-map. But at this side, simplify using the Boolean and De Morgan theorem. So you were given the things. This one is just a recap for you if you remember. So this example, this one is the things that you already learned using the rules and your law and also your theorem. But over here you have the K-map things. You can see your K-map thing here. What you need to do is you get the Boolean expression first, then you're going to map into your K-map. After that, you get the simplification, then you write and draw back your simplified versions of circuit. So it's very easy. Any question for your module 4? So I share you the simplification versions also there. Might be I'm going to save to the PDF and push to your e-learning later on. So this is how it look like from SOP, what will happen, for POS, what will happen on the K-map and etc. So you will, I will share in the e-learning. That is under module 4. Now, let's see what we're going to cover in our module 5. I think maybe we're going to have like a quick look. And after this, I'm going to share you the lab 2. What will happen to your lab 2? Wait, I try to look into your lab 2. Lab. Okay, over here. Okay, this is your lab 2. I still not yet share in your e-learning, but I will share soon. I'm going to give you 1 week to finish the lab 2. And lab 2 will be doing in a group of 3 or 4. I'm going to give a group for you. So you cannot find your own group. Okay, over here, of course, it is similar things. You need to write your name, lecturer, section, and etc. Okay, please make sure, although it is a grouping lab, you need to submit individual. Okay, individual submission. And what you're going to use is your DITS software, of course. You just need to draw the similar things here, and then after that you need to simulate and convert this logic circuit and construct in your true tables with your DIT simulator. So you need to draw your when you are running this, you let's say it is 0 for the first scenario, and then you draw your truth table and see whether what is the output for E, F, G, and X. And then you have the second scenario, you have 0, 0, 0, 1. What will happen for the output? And draw the truth table. For the second, you need to simulate the circuit, build the truth table using the following header. So it is this basically similar things. You can see here. First, you draw like this figure in your D simulator. Second, you need to simulate, which is you run and you draw this truth table and do the output. Whether what is the output for E, what is the output for F, G, and X. You can see here, choose the level or label you want, change and change the get to the drill symbol hints. Or this one, hint draw the NAND dual symbol using no. Okay, dual symbol we did not yet cover, but we're going to look into it soon, very soon, which is this part. You can see here, this is not the NAND gate, but it is a dual NAND. So you will see that it is basically like one input. So we will cover in our module 5 here. Wait, I show you. This is the things. The NAND gate as a universal logic element. So if you have like this, it is basically look similar to your NAND gate, but you can see it is only one input. So it is a NOT gate. If you have these two things, then you have the AND gate. So all this similarity, you need to remember, not only for NAND, but you're going to look into also or NOR gates like this. So later we will cover in our module 5, and you need to have that module 5 to finish your lab 2. So I'm going to speed up by providing you with the video for module 5, and later I will inform you when you're going to start doing your lab 2 and also your groups. So we take a look into our module 5 first. What are you going to look into this module 5? So first of all, you're going to look at the basic combination gates. So you will have N. Kenapa tak muncul ni? Okay, you're going to have NO logic, NO inverse logic, exclusive or XO logic, and all this logic. What will happen? Let's see. Okay, you can read by yourself this one, which is showing you about the output 0 and 1. Okay, when you have N and O logic, you combine this together. A circuit consists of any number of N gate and O gate, any number, okay? Example of expression you will get is SOP expression. AND gate here, you can see AND gate, IN gate, and you have the O gate over here. If any of your AND gate output is high, your output for your O gate is high. So this one is totally logic, because you can see if your AND gate output, this is your AND gate output, you get 1 is high, so your total output, which is your OR gate, is totally will be 1. Although here side, although at this AND gate it is 0, it's still 1 or high for your output of your OR gate. This is the things that mentioned here. So you need to remember whatever, let's say you have too long of your adding and get, but as long as you have one and get, output will be having 1, your total F will be 1, because this is the rule under O. And if all the AND get output is low, and your output will be low. So if let's say semua you punya AND get is 0, barulah you akan dapat 0 for your output. Okay, here is the things. You have AND gate and OR gate for the final value. So if let's say you have 1, then it will be 1, although the rest will be 0. But if you have all 0, your output will be 0. This is what mentioned in this box here. That's why you can see AND OR logic. Based on the truth table you were given here, derive the expression using the KMAP and implement the AND and OR logic. Okay, you were given this truth table. So you need to only draw your circuit using the AND and OR logic. So you need to simplify using the KMAP. So you have here A, B, C, D. Is it? It's give you? Okay. You need to remember, you can see, this is the things, it is under SOP. So first you're going to map your KMAP. This is the standard versions. You have 1, 1, and then you have the value of all of these, and you don't draw into the KMAP. Then from here, you will have the simplification version. You will get A, B, C, D, and then of course you're going to plus. A, B plus C, D, F. Then from here, you have 1 AND gate, A, B. Here will be another AND gate, C, D. Then you combine together using your OR gate. This is the AND OR gates. Dia tak tunjuk . So your final answer will be A, B, C, D. So it's similar to your AND OR logic. So you can see, but you have to AND get only. So try to do it. Next, you're going to have, this one is, you can try to draw this. This one is simplification, because it asks you to simplify using your Boolean algebra rules. Sometimes, as I mentioned, you don't know the final product, final simplification. So you can check using your KMAP. So try to do it, and this is your answer. Follow the step. This one I don't want to discuss anymore, because we already learned in your module 4A last time, right? Rules, law, and also De Morgan theorem. So from the simplification, you can draw your logic and or logic circuit and or logic circuit. Next is you have and or inverse logic. So this is a possibility circuit that you might have if you have this like bar there. So this it is the implemented of your NO circuit, which is you just learned just now. Example of this, you're going to have if you were given with this POS expression, it is basically from this side, which is you have N and O with the bar. N and O, and the bar will be your inverse. So your result of your circuit will be like this. N, O, inverse. So if you were given with this kind of question, draw your N or inverse. So you need to draw N or not. So you can see how basically the N or inverse truth table look like. So this is all the output given. Try to do the K-map thing. So this is the output because it asks you to have the inverse logic. So instead of having this X, you're going to have the X bar. So based on the truth table, you need to derive the expression, simplify using the K-map, which is similar, and implement using the N, or, and then going to have the inverse. Instead of X there, going to have the X bar. So you're going to look into the 0 thing, which is X bar. X bar is basically the one over here. You can see when it's going to be X bar, it's going to be 0 there. That's why you're going to group the 0 things and you come out with your POS first. From your POS, you have all of these. You're going to convert. You will get you will get this final answer, and from this side you're going to convert it to be where is it? Okay, this one. You will get like this, and you convert using your De Morgan theorem. You will have this part for your NO circuit. We will try to do it later on. I will give you one step-by-step video and try to do exercise. Okay, what we're going to look into next in our module 5, the thing that we'll cover in your lab 2, which is your universal properties of your NAND and also your NOR gates. So, what is NAND universal properties? What is NOR universal properties? So, normally you already have NAND and NOR gate. Last time you know that your NAND will be look like this, which is the inverse of your AND gate. Your NOR gate is like this, which is you have the two input there, and one output, which is basically like a toggle for the AND gate, a toggle for your OR gate. But the combination of all this is a NAND gate and a NOR gate. So you're going to use it to convert it to be represent as, you can try to read it after this. You can see from this NAND gate, you're going to have NOT or inverse by combining the input to be one input. So it is similar to not get. So this is your NAND gate. You combine the input to be one input. It is similar to your NOT gate. If you have A here, this will be A bar. And that is the first thing you need to know. Second, you're going to have two NAND gate. And then you're going to have similarity of AND gate. You can see here, when you combine together, of course, this will be one input only because there is one output. So this is the NAND gate. This is another NAND gate with the combinations of input there. This is NAND gate also. One NAND gate, two NAND gate. You will get AND gate. So try to play around with the value. If it is 0, 0, what is the output for this side? If it is 0, 1, what is the output? So you can use your DIT simulator to check. It is similar to your tables A, B, 0, 0, 0, 1, 1, 0, 1, 1, output 0, 0, 0, 1. It is similar or not to this. So basically it will be similar. So using this, you can get your AND gate representation. Why you need to know here? Because and there is a question for your test 2 or your final exam will be asked, draw your circuit using NAND gate only. So that's why if you have like A bar here, okay, let's we have F equal to A bar plus AB. Okay, we have this. So how are we going to draw? Using the NAND gate only, we cannot use OR gate. We cannot use AND gate. So how are we going to draw? We're going to draw, this is our A. To have the A bar, we will draw like this. Okay, this is our A bar there. And then this is our A bar. We need to have O later on, okay? So our AND gate. Our AND gate, we will draw like this. This is our A. This is our B. And we have already this and this. And then we need to have O, but we need to use only NAND gate. How are we going to have O in terms of NAND gate? This is the combinations of O gates using NAND gate only. So how is this? You're going to have another NAND gate, another NAND gate. This is your final F there. And you draw it using the NAND gate only. So you can see NAND gate. But later on, you're going to learn on simplification. This and this, you can see it's joined together. You're going to remove this and this. You're going to join this together. You're going to remove. That's why you will get like final answer. It will be your simplification circuit, it will be like this. This is your A here. Okay, I have this part. B, A. This is your final circuit for this using the NAND gate only. See, you don't have no gate, you don't have not gate, you don't have AND gate and extra. It is only NAND gate. So that's why you need to learn all of this representation. If not, it will be like this. If AND gate, it will be represent of 2 NAND. If it's OR, it is represent of 3 NAND gate. But you need to know how the connection is look like. And if it is no gate, you need to have only like another NAND gate in front to be assumed. This one is not right. So you just add this to your OR gate. So the very basic that you need to know, 1, 2, 3. When you know these rules, this representation, you can have the no gates over here also. Because you're just adding another knot in front. So this is a representation of NAND gate. Why you need to learn this? Although you can say, kan kita ada gate not, we have and gate. Why we need to apply using NAND gate only? Contoh, in term of the real case, kalau you nak buat sambungan circuit, if you need to combine, use your circuit, but you dah habis, it's already finished, like maybe this only you habis on in term of your not gate, but you have the others gates. So in term of missing NAND gate, you can not gate, you can use NAND gate and combine them together using the representation. How is it like this? If let's say you ada not gate, you ada O gate, but you dah habis, you punya AND gate dah habis. In term of the real hardware, okay? Real hardware. This one is already finished. So you can use the representation of NAND gate kalau you ada extra NAND gate to represent as an AND gate. Okay? So that is why you need to learn. And in the question for your digital logic subject, there is a possibility for you to be asked, draw the circuit using the NAND gate. Draw the circuit using no gate only. So that's why you need to know the representation. So that is AND gate. So later on you can see you have all of this example. If you have this one is what question? Okay, so you were given this question. It is very simple. What will happen? Later I will show you, but I just want to go through, right? So all the example we're going to look later, okay? Okay, now go for your no gate. It is basically similar. Sekejap, I nak tengok WhatsApp sebab I don't bring my phone. Okay, at 11 I have presentation. Okay. Now continue back. Okay, you can see here, it is basically similar. If you still remember when you join the input at your NAND gate just now, you will get your NOT gate. Similar to NOR gate, you can see, combined together is going to be your NOT gate. As mentioned, kalau lah you punya dalam real hardware you tak ada, doktor tak ada pun NOT gate ni, macam mana kita nak buat circuit I tak boleh nak jalan lah semua, then you need to use the other way lah. This is the other way for you to use the NOR gate just to represent the NOT. So in terms of that, you can see also just now when you have two NAND gate, you ada AND gate. When you combine this NAND, you will get AND. When you have no plus no gate, you will have OR gate. So you can see, you combine this, how to check, you can use this simulator, look into whether it is correct or not. So you combine this like this, please remember the connection, and you will get O gate. And similar things, you can see the similar connection to the AND gate, you're going to get your NOR gate just now. O gate just now, and here it is combination of your NOR, you will get AND. Just now combination of your NAND, 3 NAND gate with the following connection, you will get O gate. And adding another gates and another NAND gate, which is 4 NAND gate, you will get NOR gate. But from here, and for NOR gate, you will get NAND gate. The way how you represent, you need to remember the connection. So there is also example there. I will provide in the video, basically, which is similar. Okay, now what else we will look into your module 5. So it is dual symbol. What is dual symbol? Dual symbol, if you have NAND gate, you can also have NAND gate in terms of OR gate, but you put bubble inside in front. It is a negative O, but it's represent as a NAND gate. It's called as dual symbol. Dual symbol. Dual symbol sejatuh dah. Aduh. Okay. Now you can see here, you have a NOR gate. You can represent your NOR gate by using your dual symbols there, but it will be your AND gate with the negative. So converting to alternate symbol. So how are you going to do? You're going to pull the bubble in front, and then change the symbol. If AND gate, you can see, if AND gate to OR gate, and then OR gate to AND gate. So this bubble you're going to bring in front. This bubble you will bring in front. So that is the dual symbols. So when you have a circuit, later on you're going to simplify before you have the final answer. When you meet with another bubble, you're going to cancel. When this bubble meet with another bubble, you're going to cancel. Bubble cancel the bar. So the purpose of this, you're going to meet this one. So you're going to remove that's why there is no bar after that. For this side, you can see. So bubble cancel the bar. That is the things that it mentioned here. Bubble and bubbles is going to cancel because it is not and not right. So bubble at the bar. You can see here, bubble will add the bar. From D to D bar. From E to E bar. Because it is similar to your NOT, which is your inverse. See over here, there will be given you a question. Convert your S of P circuit here to NAND gate only. You were given A, B plus C, D. You can see it is AND gate, it is a OR gate, it is a AND gate. By using the NAND gate only. It's mentioned. So what you're going to do, you need to remember, okay, in terms of this, it asks you to do the bubble thing first before you go for the NAND gate. So put the bubble first, because it is basically similar. The thing is similar, which is cancelled. And then second, compensates the effects of putting bubble, add another bubble at the output of AND gate. Replace the negative OR symbol with the NAND gate symbol. So let's take a look. You have, mana IP pencil? This one is remain, which is if you have this, if you remember at the first side here, going to have this negative or it basically the NAND gate. So you can see here, when you first putting the bubble, already put the bubble, it's going to be from AND gate. Dia akan jadi your NAND gate because you put the bubble. Bubble. Why you put here and here? Because it's basically nothing happen because it's cancelled each other. But you just put it because you want it to be NAND gate later on. So you put here to be NAND gate, you put here to be NAND gate, and when you have this, you can change it to be NAND gate. So that's why you will get like this. So you can also have the converting of POS. Just now is SOP. So you're going to convert the POS circuit to NOR gate only by putting the bubble. And then this side, if you remember at this slide, it's going to be a NOR gate. Like this. So it is only NOR gate. You can see. So dual symbol NAND only. So how you going to see? You going later on to learn on odd and even. Yang ini a bit confused. We're going to cover it later on. So I'm going to teach and push the video until these conversions. Later we will learn in our class on the dual symbol. If I can speed up the video, I can also include, because there will be a possibilities for you to be asked in your test 2 only and your final exam for the odd and even. So that is on NOR and NAND gate. Later on, you're not going to look into OR gate, the basic gate, because the basic gate is just a representation. Instead, you're going to draw in terms of NAND gate, NOR gate circuit. Any question for now? After finish our module 5, we directly do the lab 2. After lab 2, I'm going to push with your, I guess, next week, with the group assignment, group project. There is a group project that you're going to do with a grouping also, the group that I give for your lab. So any question for your module 5 and your module 4? So I hope that before you go further in your module 5, watch the video first. You have another 30 minutes. Go for your e-learning and then watch the video I provided for you to finish the module 4B. Is it okay?
Yes.
Okay, betul.
Okay, if there is no more question, for those who still not yet, scan your QR code. Please scan at your e-learning. And then for the rest, please watch the module 4B video first, because after this, I'm going to push your module 5 video. Okay? So if you cannot, if you didn't understand the module 5, you cannot answer your lab 2. Okay. So thank you for your participants. Stay safe and have a good day. Bye-bye.
Thank you, Doctor. Have a good day.
Thank you, Doctor.
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 Bye-bye.
Thank you, Doctor.
Thank you. Bye, Doctor.
Okay. Bye-bye.
Doktor,
Ya?
tarikh test 2 bila?